Thank you very much too. First of all, I would like to thank you, ASHRAE, for the invitation, for the opportunity to me to be here and to make this presentation. Thank you very much. So I will start with my presentation. The topic of my presentation is implementation of energy efficiency measures in the retail supermarket. This is the agenda which I will present in the next minutes. So here we see the energy performance. It's typical KPI, key performance in the energy performance index in the supermarket retail sector. So we see here the continuous improvement. This figure is going year by year, it's going down. So, and also here we have the carbon footprint. It's from year 2013 until the year 2024. So we see here this scope 1 and scope 2, the indirect and direct and indirect emissions during these years. So we see here a gap from the year 2018. It has to do with the energy. It's due to the GOs, the green energy, the purchase of the new energy. So this is the reason why we have this reduction of the carbon emissions. So one energy efficiency measure is a voltage power optimization system, which we have implemented in the last years. So as you see here the schematics. This is an auto transformer with a patent in the secondary winding, which optimize the power quality. I will show you the next slides. So you can see here the diagram of the voltage. It's you can see here it's how it is the fluctuation of the voltage, and then you have with this system you have the output. It's like a DC voltage. It's very stable. The output. Next is so. With the system we can achieve energy saving from 5 to 10% of the total energy of our store, total energy consumption. You have a precise voltage stabilization and optimization, three-phase balancing. You have the three phases very closed. Voltage correction, it will be done by the control unit. You have also compensation of reactive power. This means that you don't need capacitors in order to compensate the reactive power of the loads. No moving parts, protection of the electrical installation and the electronic equipment, 15 years of warranty, and the expected life of this system is over 100 years. This is also very, very important for this system. In this diagram, you see also the compensation of the reactive power with the optimization. You see the cosmos P, but how it's going up. Reduce of harmonics, protection of overvolt voltage. You see also the pre-install and after post-install. In this table, you see the process that we have done in the company in the last years. We have started with a pilot project in the year 2017, and after that we have continued with 4 stores, and until 2024 we have implemented this project in 27 stores and 1 distribution center. And for this year, for 2025, we have also a planning of a budget of 85,000 euros to install 7 additional systems in 7 stores. So here in this table you can see we have the energy efficiency and also the energy savings cost. You can see the percentage of this system. This is the energy efficiency of the total consumption of the store, and for the distribution center it's smaller. The energy efficiency is approximately 3%. I would like to mention that in comparison to the other installation, this is a unit without. This is a system without control unit. It's a simple system. This is the reason why we have smaller energy efficiency. But you can see the total energy savings and also costs from this project. It's huge, and also the payback period is short. It's 3 to 3.5 years for this project. So some case study here. You can see this was the first pilot project in 2017. It was implemented in June. The annual energy savings, the annual cost, and the payback period. And also, you see here the method of with the EinB measurement, with the methodology. You see here the voltage of the head node of the distribution, of the input of the facility, and the output of the voltage after the system. How is the difference? And also, you see here also the unbalance and the stability of the optimization of the 3 phases of voltage. So the next measure, it has to do with the evaporative condenser cooling systems, which we have started in the last years. It is a batch system that increases the temperature of the inlet temperature of the rooftop condensers. It's very important for a supermarket during the summer, and which we have the last year. We have heat waves the last years. We have many days with very high ambient temperature. So this measure is very important in order to reduce the temperature of the condensers and to improve the efficiency of the cooling system. So by decreasing the inlet condition, you can increase the risk of the high pressure alarm, increase the efficiency, as I have mentioned previous. And for the reduction of 1 temperature centigrade at Celsius, we have on the inlet of the condenser, we have a minimum energy efficiency of 2%. On the other hand, we have to mention here that we have to take into consideration during the design phase of the system. We have to take the local climate condition, the availability of water, and the special cooling requirements. It's very important these parameters to take into consideration for the design of the project. So, in this figure, we see the concept of this technology. So, one temperature ambient temperature goes through the HC cool matrix, so it comes in contact with the water that flows freely across the matrix, and heat energy is absorbed by the water, causing the evaporation of the water and cooling the air. You can see here the difference of the temperature from 40 degrees Celsius going to 26. So the pre-cooled area through the condenser allows the heat energy from the condenser oil to dissipate more easily. And this this increase the cooling capacity for the same, or in most cases, less energy consumption. And as I have mentioned previous, every one Celsius centigrade reduction in temperature on the inlet of the condenser, it increased the energy efficiency of the condenser by 2%. Here we see some photos we have from some pictures from installations. It's a real case. You see here. This is also measurements which we have taken. Here you can see the temperature suction line with the system and without the system. You can see the difference also for the temperature liquid line. The same also for the temperature suction line, the condensing pressure, you can see the difference. So, and here we can see the benefits of this system. We have an energy efficiency of 20% at a temperature of 32 degrees Celsius. We have expected higher energy efficiency in case the external temperature is higher or also the humidity is lower. With this system, we can also reduce the peak loads. This means that we have a better load management, reducing the refrigerant leakages, which is very important, especially for the summertime when we have these heat waves and we have the high ambient temperature. We have many leakages this period. So this we also reduce the CO2 emissions. Scope 1 is for the leakages, Scope 2 is through the energy consumption, lower maintenance costs, and also increasing the lifespan of the compressors. And here we can see a transition plan of the company for the next years in order to go to the zero net carbon emissions. So you can see through all the energy efficiency measures on the projects which we plan every year in the company. This is a long-term planning for the next years in order to achieve the targets and to go to the carbon neutrality. So the conclusion is that sustainable solutions with high impact in transition plan, adaptation of refrigeration system to extreme heat waves during the summer period, attractive investment opportunities, reducing of peak loads, improving energy efficiency, reducing the operation costs, and the extension life of the equipment. So thank you very much.